Okay, class, we pick up with, let's see, we are unit what? 2.7. We're right towards the end here. We're going to do two problems, and you're going to have a significant amount of work time, okay? So it says this is a real type of problem that you do see, and studies show this, and this is how you would figure it out. Hopefully your marketing team actually figures it out for you, but I guess if you were on a marketing team, maybe you'd be the one doing the work. So a hockey team plays in an arena with a seating capacity of 15,000. Ticket prices are $14 a piece. Average attendance at recent games has been 9,500. So they're not selling as many tickets as what they could, right? So they're wondering, if I lower this ticket price from $14 to something, then maybe the attendance would go up. Well, a market survey indicates that for each dollar the ticket price is lowered, the average attendance increases by 1,000. So find the price that maximizes revenue from ticket sales. It's hard to draw this, but basically we could maybe write this as a model. As we say, ticket prices goes down, what goes up? Attendance goes up by how much? By 1,000. As the ticket price is lowered by a dollar. So, you know, that doesn't necessarily give us a picture, but it does help us understand more critically what's actually going on. How would I calculate revenue? How much money would you get from an individual game? How would you calculate it? Don't give me numbers, give me an expression. Okay, revenue is equal to attendance times price. So I need to write two expressions. It'll be more than that. But I need to write an expression for the attendance, and I need to write an expression for the price. Okay? So let's have the price of the ticket equal X. Then let's do this. We need to lower it by a certain amount, right? So let's say that let's say the ticket price was $13. How much did I lower it by? You took 14 minus 13, right? So the amount we reduced it by would be 14 minus X, 14 minus the ticket price. So if our ticket price was 12, 14 minus 12 is 2, we lowered it by $2. Okay? We also need attendance increase How much does the attendance go up by? 1,000 times what? 14 minus X. Not the ticket price, but the number that we lowered it by. Now, you guys, if you choose to do this problem in your assignment, you're going to want to watch this example. You probably won't come up with all of this on your own right away in your head. Okay? But that's why we model the problems so you can get used to them. If you saw them again, you'd know what you were doing. So, I kind of had this last piece here, and that would be, well, we said revenue is equal to attendance times times the number of or the cost of the ticket. Let's actually look at the actual attendance. What is the current attendance? 9,500. And what's going to happen to the attendance, we hope? Go up by how much? By 1,000 times 14 minus X. I have enough information. We're trying to calculate maximum revenue. What should be the name of my function? R of, what's my variable going to be? X. So the revenue in terms of ticket price, X represents ticket price, is equal to A times P. What's P? What's my price? X times, what's the attendance? Plus 1,000 times 14 minus X. So, yep, we've got a double set of parentheses there. We just got to modify that equation, and we'll be able to figure it out quite simply. So I'll distribute that through. R of X is equal to X times, let's see, 9,500 plus 14,000 minus 1,000X. So if we combine that together, R of X is going to be, let's see, 9,500 plus 14,000 is 23,500. So 23,500X minus 1,000X squared. Not easy, but do you see where it all came from? You see how we got this equation from those pieces. Ticket price is X. We figured out our attendance up there. The 9,500 plus the additional people that come in, which was 1,000 times the amount that we drop each ticket by. Okay? So now it's time to solve it. What are we trying to do with this? We're trying to find the max. If we graph this thing, what does it look like? A parabola. Very good. So I draw it. That's the maximum. It occurs at negative b divided by 2a. F of negative b divided by 2a. That is the point of my vertex, which we have learned over and over again. You've got to commit that piece to memory. What is negative b? Negative 23,500 divided by, what is 2a? Negative 2,000. We divide that, we get 11.75. A for the day, what does 11.75 represent? The price of the ticket, how do you know that? Because that's X, and we set up here that X represents the ticket price. Good. What am I trying to solve in the problem? Find the price that maximizes revenue from ticket sales. So we found the price. If they asked for the maximum revenue, what would we do with that? We'd plug it back into here. That would give me revenue. What if I wanted to know what the attendance would be? Okay, I could put it up here and solve, or I could take this and put it in for X here. That would generate for me the attendance. So notice the different equations you have floating around. This is why we organize it in this way. Any questions on this problem? Okay. We got one more then. You guys are so smart. A rectangle is inscribed in a semicircle of radius 16 inches. What should the dimensions of the rectangle be in order to maximize the area of the rectangle? So I'm going to sketch a little graph here, a semicircle. So we're going to say it's on the upper portion. And what I didn't put in the problem is that the rectangle's base is going to sit on the x-axis. If the circle is going to be drawn, and let's say it has a center at 0, 0, what would be the maximum height on the y-axis that the circle would reach? Very good. What spot would it cross on the x-axis on the positive side? 16. How about the y-axis? Negative 16. Very good. So I have my semicircle. True or false, that is a function. True. If I drew the whole circle, would it be a function? Nope. So that's something we'll keep in mind for later use, but that's what this graph looks like. Okay? So I got a circle. I'm inscribing a rectangle inside of it. So I've got this rectangle. Looks like this. So inscribe means in, circumscribe means about, on the outside of it, okay? Circumscribe. Tyler laughs at that word. All right. Circle, sure. Okay. So tell me, I have a coordinate here that I will have to generate eventually, but what should we call this coordinate right here? We'll call that x. What would this be back here? Negative x. And we'll get to the rest of it in a second. There's just a little trick here. Not too bad. I think you guys will understand it very well. But with that said, I'm trying to maximize the area. So what is my formula that I'm working with? Area equals length times width. Now, nobody liked my drawing. They said, we don't like it. We would like you to do length times height. Because they said that looks like length to them, and that looks like height. Do you care? Okay. Length times width. We'll say width is the bottom, length is the height. What is the width? Very good. A for the day. Who can tell me the length, the height, how far up it is? Tricky, tricky, tricky. Y, what is the Y value? Good try. We'll use that 16. I think we need an equation for a circle. Who can tell me the equation for this circle? Centered at 0, 0. X squared plus y squared equals r squared. Remember that the equation for a circle is exactly the Pythagorean theorem. X squared plus y squared is equal to the radius squared. Yes? So that's the equation for the circle. Okay, a little bit of remembering, now we got it. I should solve for y because you guys said I need to use y, so we'll do that. How are we going to solve for y in this situation? So I have y squared is equal to 256 minus x squared. I need to square root both sides. I do that, and I get my length, or my height, is equal to the square root of 256 minus x squared. Now, when I square root something, I get a positive and a negative, don't I? Well, which piece am I looking for, the positive or the negative? Yeah, because this is a semicircle. So I'm just looking for the top half. So that is the equation for the semicircle in the upper portion. Do I have an expression for my width? How about my length? That's all I need. Somebody name my new function. A of x, area expressed as x, this coordinate, will be equal to what? Excellent. What does that look like? You have no idea. Well, yeah, that would be nice, except it's got this x squared, which changes it, and it's also got this x in front, which changes it. So I don't really even know what this looks like. So, well, I do because I taught it second hour, but otherwise I really didn't know. And so we don't have the ability to find this maximum without the use of technology. If we had calculus, we'd be able to. So we type it in, 2x times parentheses, or square root of 256 minus x squared. Now, to help you out, again, let's look at our viewing window. What is the largest x value that you could have in this situation? 16. What's the smallest x value? 0. Because Whitney, if this was say 0 here, then this would be 0 over here as well, because that's a distance. So that's why. But good thought. So if I put my viewing window from 0 to 16, I should see the whole thing. So I'm going to go my viewing window. I go 0 to 16, and I'm going to go all the way up to 400 for my max, because I did this in the class previous. And hopefully that will give me a nice view of my graph. And when I graph it, I sure do have the view that I'm looking for. Yeah. Went up to 400. Yeah. I think when I first did, I went up to 100. I couldn't see everything. You could see this probably goes up to about 200 or 256. Anyway, so we want to find the maximum there, though. You can see this interesting shape. It's definitely not a parabola. It almost looks like half of a heart, huh? Oh, broken heart. Oh, sad. Okay, so we want to calculate the maximum. How do I do that? Second, calculate. Number 4, maximum. Left bound. Let's go to the left of this thing. Enter. Let's move to the right. Enter. Enter on guess. I get 11.31 and the y value is 256. So we get that shape. The maximum occurs at 11.31 and 256 is my y value. Tell me, what does 256 represent? R squared, which also happens to be the area, the maximum area. We're not looking for that. We're looking for the dimensions of the box. What does the 11.31 represent? The distance along this x-axis here. So that's your x value. You got to look back at your picture. So if 11.31 is here, what's the length of the entire base? 22.62. So the width of the rectangle is 22.62. Notice we just plug our x value in for the width. Then we need our length. So we plug it in there. Square root 256 minus 11.31 squared. Square root that. I get 11.31 back out. So the length when we type that in is 11.31. Those are the two dimensions for a rectangle. That will maximize our area, which happens to be a maximum of 256. That concludes 2.7. Any questions? Okay.